Hello everybody, this is 10.8 and 11.1 together. Please print out the notes and follow along. So this is actually going back to our quadratics from last unit, but there's a reason why this is being taught now. So the last unit was quadratics. Remember, it was solving and a degree 2 equation. So we are going to look at these and solve them algebraically and graphically. So remember, how do you solve something like this? If it's a squared, you need to think about factoring. Okay, so remember there's no GCF, so you're going to go straight into two binomials. Okay, so think back to last unit. You need factors of -6 whose sum is 1. So here are the factors. Individually set the factors equal to 0. Let me just quickly go back. Remember, you need things that multiply to give you -6. So the lasts have to multiply to give you the lasts. And actually, this was 2 units ago. Gosh. Okay, not the last unit, but the unit before. And the inners and the outers have to combine to give you 1x. So 3x and -2x. Let me just write that down. 3x, -2x, and when you combine those, you get 1x in the middle. So then individually set the factors equal to 0. You're using the zero product property. You get x equals -3, and here you get x equals 2. So let's look at the graph of this thing, because you want to solve it algebraically and graphically. So we did these in that same unit. Oops, hold on. So here's the graph of that thing. Just look at, actually, hold on, let me backtrack. Look at the y equals. So I typed that in. I have those typed in for the next two. So I'm just looking at the graph of that thing because I have that equals sign highlighted. So if you look, it crosses the x-axis at -3 and at 2, which are the solutions. And we did that during that unit also. So this is just a reminder. So it looks something like this. Okay, and the solutions are -3 and 2. Okay, so let's look at this one. If you go to solve it, you factor. You need factors of 9, and the inners and the outers have to give you -6x, and this is what works here. So you get x equals 3 twice. When you list the solution, you do not have to list it twice. But let's look. So if you graph that thing, so now I'm going to go back, turn that first one off, and then turn the second one on. Let's look at that. So we know x equals 3 is the solution. So if you look at the behavior, and I think we had a name for this, it was called a double root. It bounces off the x-axis at that place. So that's what happens when it's a solution twice. The behavior looks like this, okay? And then what about that guy? Okay, well, we really don't have methods to solve that yet. So if you try this, this does not work for the factors because when you FOIL it together, you get x squared plus 2x plus 1. So that does not work. If you try a +1 and a -1, when you FOIL those, you get x squared minus 1. And that's not the original one either. And a minus doesn't work because it gives you x squared minus 2x plus 1. So that does not work either. Okay, let's look at the graph. So an interesting thing about that is it does not cross the x-axis at all. So it doesn't have any x-intercepts. So let's look at it. So how many real number solutions can a quadratic have? So this does have solutions, but they are non-real. So this is considered 0 real solutions because it does not cross the x-axis at all. And that is a quadratic that we have not learned to solve yet. Okay, so this is 0 real number solutions. This is 1 real number solution because it touches the x-axis in one place at 3, and this is 2. So because it touches the x-axis in 2 places, it crosses the x-axis. So a quadratic can have either, so I'm going to put no solution. So it can have 0, 1, or 2 solutions. And I'm going to put that they're real, and you'll see why in a minute. Okay, so it can cross the x-axis twice, once where it just bounces off the x-axis, or not at all. Okay, and we prove those by looking at the quadratics and solving them. So now we come to that last problem. So let's look at this. And if you want, you can look at this video on YouTube. So the complex number system was invented so that we would have solutions to problems like this. Okay, so if you're solving this, you would bring over the -1, and you would take the square root of both sides. When you root both sides, you take plus or minus always. I'm going to talk about this. I'm going to talk about this later when we go through to solve. So you get root -1, and in the past you've been told that you cannot take the square root of a negative number. It's non-real. You actually can take the square root of a negative number. It's just that we did not know that number system yet, and the number system is called the complex number system. So the square root of -1 is I, and you always, when you root both sides, you always need plus or minus. So square root of negative numbers do have solutions. They're just not real solutions. They're in the complex number system, and the complex number system includes real numbers and numbers with i's in them. So the number I is equal to the square root of -1. I'll stop this video and come back with the next video on simplifying radicals in a minute.